All right, so here we go. We're going to continue with 2.5. Example 6 says find a fourth degree polynomial function with real coefficients that has -1, -1, and 3i as zeros. Now, based on what we learned yesterday, I know the fourth zero. What is it? -3i, because complex conjugates are zeros. So if you know one, you know the other. So here we go. This is similar to example 5. Whoa, what did I do? Isn't that weird? Okay, so I have x plus 1, x plus 1. I'm getting x minus 3i, and then x minus -3i would be x plus 3i. So this is very, very similar to example 5 from yesterday. So we're going to use the associative property and multiply the first two together and then the second two together. So the first two will produce x squared plus 2x plus 1. And then the second two, the outer and inner cancel, and I get minus 9i squared. Since I squared is -1, that's x squared plus 9. We'll use the extended distributive property to take x squared times both terms, so we'll get x to the 4th plus 9x squared. Then we're going to take 2x times both terms, 2x cubed plus 18x, and then we'll multiply by the 1. Collecting my like terms, f of x equals x to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. Alright, I'd like you to find a sheet of paper, and we're going to do one that's a little bit more difficult than 5 and 6 because it's in your homework, and I want to make sure you're sufficiently prepared for your homework. So here it is. It says write a polynomial function with the following zeros. 2, 4 plus I, 4 minus I. Now, if you saw this problem and they said, okay, you have zeros of 2 and 4 plus I, you have to understand as the pre-calculus student that 4 minus I is automatically another 0, even though they didn't explicitly come out and say it. Alright, so now watch this. We're going to write f of x equals. Now, if 2 is a 0, we know x minus the 0 is a factor. Remember our factor theorem? Now, here's where the problem comes in. If 4 plus I is a 0, it's x minus the 0. That 0 is a sum, so we're going to have to subtract the sum. And then we're going to get x minus the 4 minus I. Alright, so at first this is going to look a little bit scary, and then it's going to work out beautifully. So here we go. I'm going to tidy it up to be x minus 4 minus I times x minus 4 plus I. And you can only multiply two things at a time. So what I'm going to suggest is when you are multiplying the factors of complex conjugate zeros, you want to group those together because watch what happens. It's going to get ugly first and then turn out beautifully. So watch this. And do you guys remember back to Algebra 1? This is what's so fun about, I love pre-calculus. Just love it. Do you remember, Algebra 1? Do you remember when we used to do this stuff in Algebra 1, where you would multiply a trinomial times a trinomial? guess what? You get to use that skill right here, and you didn't know it was coming. Okay, so here we go. Isn't that cool? That is really cool. All right, so here we go.
Your subscribers are going to love this.
X squared minus 4x plus xi. And then we're going to take the minus 4. And I'm going to get minus 4x plus 16 minus 4i. And then we have to take the I, the minus I actually. So I'm going to do minus xi plus 4i. Minus I squared would be a plus 1. Okay, now I realize that looks horrible right now. The good news is, whenever you take your factors of complex conjugates, okay, your complex conjugate zeros, guess what's going to happen every single time? All the i's cancel. So my xi cancels, I don't know what I keep hitting here. My xi cancels, my 4i cancels. So f of x equals x minus 2 times, I have x squared minus 8x plus 17. Whew, okay, that's a lot nicer to deal with than what we started with or even got to the middle of the problem. Now we're not done. We have to take the binomial times the trinomial, but it's a good thing this is fun. This gives us x cubed minus 8x squared plus 17x minus 2x squared plus 16x minus 34. Collect your like terms. I don't know why oh, I'm using this one. I hate this wand, that's why. Sorry. I don't know, that wand just does not like me. You know, it has feelings, right? Alright, so it's x cubed minus 10x squared plus 33x minus 34. So when you get to the problem like this in your homework tonight, you'll now know you have a good example to look at. Okay. Alright, then let's go back to the notes. And we are up to example 7. It says factoring a polynomial. It says find all zeros of f of x given that 2 plus 3i is a 0. Well, what do we know is also a 0 then? 2 minus 3i, okay? Because complex zeros, whoops, always come in conjugate pairs. So we also know 2 minus 3i is a 0. All right, now, we're asked to find all the zeros. All right, well, let's think a minute here. If I have 2 plus 3i, that'd be a first degree, right? And 2 minus 3i is a first degree. If I could write out their factors, and I just learned that if I multiply out their two factors, it turns out pretty nicely. There's no more i's involved. Couldn't I do long division? Couldn't I take my f of x divided by whatever that product is by the two complex zeros? If I do long division, that'll take me down to an x squared, because I'm taking an x to the 4th divided by an x squared. Oh, all right, so if you don't quite see it yet, that's okay. Let's start it. So I'm going to take x minus the 2 plus 3i. Notice you have to put complex zeros in a parenthesis. Okay, so even if you didn't quite follow what I just said, maybe when we work it out, your light bulb will shine. So I'm going to get x minus 2 minus 3i times x minus 2 plus 3i. All right, so we get to multiply this out. I get x squared minus 2x plus 3xi minus 2x plus 4 minus 6i minus 3xi plus 6i. Now it's minus 9i squared, but I squared is negative 1, so it's going to be a plus 9. Remember what I told you on that extra example? Your i's should cancel when you're multiplying out the factors of complex conjugate pairs. If they're not canceling, your i's aren't canceling, you made a mistake. And you just need to go figure out where it is. So now I'm getting x squared minus 4x plus 13. Okay, so now let's make a connection to what we did earlier, is that if you have a 0, you have a factor. You can divide by that factor, typically with synthetic division, if you're doing a linear factor at a time. This time, though, I have a quadratic. So I'm going to take x squared minus 4x plus 13 into x to the 4th minus 4x cubed plus 12x squared plus 4x minus 13. And that's going to create a quadratic equation. So the good news is, if it doesn't factor, I can always use quadratic formula. That's always my backup plan. So I'm going to need to multiply by x squared. So I get x to the 4th minus 4x cubed plus 13x squared. Then I add and I get negative x squared plus 4x minus 13. So that's a what? A minus 1. Well, isn't that convenient? There's no remainder. So then if I want the other zeros, x is plus or minus 1. But let's go back and reread the problem. And I know I mentioned it yesterday about the quiz I returned. We need to make sure that we are answering the question. It says find all zeros. So plus or minus 1 isn't all the zeros. So we're going to write that the zeros are plus or minus 1 or 2 plus or minus 3i. If you had an answer blank, that's what's going to go in your answer blank or your box if you're circling your work. Now also consider it was a 4th degree polynomial. And there's 4 answers, right? Okay. In example 8, x squared plus 1, we can now, if you remember through Algebra 2, we said the sum of 2 perfect squares will not factor over the set of real numbers. That is still true, but if you want to factor it, you can factor over the complex numbers. So, for example, if I gave you x squared plus 36, how is that going to factor now? X plus 6i, x minus 6i, right? And then if we were trying to solve this equation, you know, my two solutions would be plus or minus 6i, okay? All right, a quadratic with no real zeros is said to be prime or irreducible over the reals. Last year we just said does not factor, DNF. Another thing we're going to do in pre-calculus is if we have x squared minus 2, we're going to factor that now as x minus square root 2 times x plus square root 2. So we're going to include irrational in our factoring. All right, example 9 says write f of x as the product of linear factors and list all of its zeros. This is an awesome problem. You're going to see all sorts of mathematics come out on this one problem. All right, if you remember a previous section, they would give us a 0 to start with, and then we could do synthetic division and get it down to something we could work with. They gave us nothing and said, factor it completely and list all the zeros. Well, yesterday when we did the first part of 2.5, we put a tool in our tool belt. What's going to help me come up with at least one of them? What's that thing called? The rational zero test, okay? The P and the Q's, that's right. It's called the rational zero test. Now, since the Q is 1, let's not waste our time writing both of them out. Let's just go directly to P divided by Q. So it's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Okay, do you see that? If Q is 1, don't write out P and Q, just do P divided by Q. All right, so go ahead and find your calculator. put x to the 5th plus x cubed plus 2x squared minus 12x plus 8 in your calculators. Scroll up and down the table, unless you want to use your ask feature. Either way is fine. But now we have so much mathematic power, okay? We have a ton of power now. You can look at an x to the 5th and you can come up with some possibilities with the rational zero test. That's like awesome. I think scrolling up and down the table is faster on this one, but you don't have to. You can do ask. But then you're putting 8 numbers in there. All right, I got 1 and -2. Okay, now, Houston, we have a problem. If I did synthetic division and I divided by the 1, that would take me to an x to the 4th. And remember how we talked about a depressed polynomial? That's just reducing the power. If I divide it out by -2, that's an x cubed. I'd be stuck. But it's a good thing that we have mathematical power here. And what I want you to do, watch this, okay? I put it in my Y screen. Do zoom 6, and I want you to look at this graph, okay? And I'm going to make a connection to what we did in a previous lesson. Not yesterday, but the week before. Okay, here's the cool thing is, remember end behavior. You have your x to the 5th, okay? So I can tell it just went up and came back down, but I don't really care. I don't need to see that little piece there. But here it is. Now, do you remember, it was in section 2.2. What does it mean when the 0 is crossing through the x-axis? Tyler?
It has one multiplicity.
It has an odd multiplicity, so the smallest odd would be 1. And what did it mean when it was bouncing off? It was even, right? Oh. Do you guys get it? I mean, do you get that connection that, oh my goodness, how exciting. Do you see that now at x is 1, I know that that's happening a minimum of twice. Well, isn't that going to help me? That's going to take me from my x cubed to down 1 more to an x squared. Okay, so here we go. So I know it's like, so this has multiplicity 2 at least. It could be 4. So here we go. Let's put a 1 in. I know, isn't it exciting? I just can't wait to find out. Like I don't know. Okay, I've already worked this one out once today, but
That's okay.
well, let's pretend. Okay, let's pretend I don't know. So we're gonna do 1 twice. So now don't lose your x to the 4th as a 0 because it disappeared. So you bring down the 1. And because of space, okay, now this is an x to the 4th, right? We know this is x to the 4th. We got to remember that. Now we're going to take the 1 into this, but now our remainder's underneath the -8. So we're going to do it again. And this makes synthetic division just so fun to do. Now I'm down to an x cubed. And now we're going to do the -2. And that's going to take me down to an x squared. So I bring down the 1. And so I'm getting x squared plus 4. Now we do want to work on our reading the problem. What is the problem asking us to do? The first thing it said was write f of x as the product of linear factors. Linear factors are like mx plus b, where you have an x to the 1st. You do not have an x squared. So now this is going to connect me to example 8 here. So to write the linear factors, I have x minus 1, x minus 1, and let me not forget my f of x. I'm rewriting f of x with linear factors, and then I can't put x squared plus 4 down because x squared is quadratic, it's not linear. So what am I going to put down instead of x squared plus 4? not a square root. X plus 2y, x minus 2i. Remember, the sum of two perfect squares is going to be imaginary. Remember, our x squared plus 36 was x plus 6i, x minus 6i. Alright, that's the first part. Write f of x as the product of linear factors. So remember, x squared is not allowed. Then it says, list all the zeros. So here are the zeros. I have plus or minus, not plus or minus, sorry. They're both 1. Okay, I have 1, maybe. I have a 1 with multiplicity 2. I have negative 2, and I have plus or minus 2i. I mean, do you see this? We have the rational zero test. We have synthetic division. We have understanding tangent or bouncing off the x-axis graphically or passing through. We have factoring. I mean, this is amazing, all that we're putting together here. Okay? All right, so that's as far as we are going in this lesson. If by some accident I gave you something with Descartes' rule of signs or upper lower bound, do not do them. Okay? Do not do them. But I